All right, test. Good evening, everyone. It's Tuesday night. It's time for the Leitner Observatory Public Night, which for the last 4 weeks has been a live stream until today was from my house. But I'm happy to say I'm now up here at the Leitner Observatory on a clear night, clear, chilly night. Sun's going down in the west. I can see the sun's still shining on the hills over across the bridge over there. Let me put the camera on the telescope, me and the telescope, so you can see what's going on. All right, how's everyone doing tonight? Nice to be back at the observatory. Yale campus is not open, really. The observatory is not open. Certainly Yale campus is not open to the public. The observatory is not open to the public. But we're starting to open up some of the facilities for non-essential research as long as certain restrictions are met. So I was able to get permission to come up to work at the observatory to get ready for our summer research program, which is starting in about a month and a half. And normally we have students who come to campus to do research here at the observatory with us. But we're doing that program online. So there's some things that I need to do to prepare for that summer program. One of the things I'm going to be working on is setting up our dome over here that contains our 16-inch telescope, which is our main research telescope, the telescope that we use for advanced projects and some student research projects. The telescope is actually robotic. It can be controlled over the internet, but the dome is not. So normally when I teach labs or advanced projects, someone has to be in the dome to open the shutter and rotate the dome and so forth. And since I'm going to have students doing remote observing from all over the world this summer, they need to be able to control the dome. So I'm going to be working on installing a new dome rotation control, which will be a nice upgrade. Normally I like making the students go out into the dome and look at the telescope and realize, oh yeah, there's a real telescope in there that I'm using. But can't do that remotely, obviously. Again, I just want to be clear, the observatory is not open, Yale campus is not open. I'm still going to be doing these live streams on Tuesday nights, presumably from the Leitner Observatory, but I do have permission to come in and do setup for my summer research program. I'm trying to stay away as much as possible, of course. It's still a good idea to stay at home in the situation that we're in, so I'm staying at home almost all the time and coming in occasionally on clear nights, especially to do some tests and do some maintenance and cleaning and setup and so forth. So no one's been in the building for quite a long time, and so there's cleaning to be doing and so forth. There's a bird's nest in one of the trees right over there. It's like the dolphins in Venice. There are bird's nests inside the trees inside the observatory gateway. Anyway, what I want to do tonight is talk a little bit about what's up in the sky, similar to what I talked about last week and the week before, and talk a little bit about galaxies. And I did have a planetarium show prepared, but I don't know if I'm going to show it or not, just because I may talk about galaxies a little bit more. It may take up some more time doing that. If people have questions, of course, you're always welcome to post your questions in the chat. I'll try and keep an eye on the chat. If you have questions about the observatory or telescopes or galaxies or anything like that. And then as it gets darker, I will show some things through this 8-inch telescope that I have right here. And in fact, I already have it pointed at something. Let me switch over to this target. So what I have going on here, I have the same 8-inch telescope that I was using last week at my house, and actually exactly the same mount that I was using at my house in the backyard last week. But I'm using obviously a different pier. We have these 4 cement piers set up for putting up temporary telescopes for teaching and labs and public night and things like that. If you've come up to a public night in the last 10 years, you have probably looked through this 8-inch telescope using this mount on this pier at some point. And I'm using a different camera. I actually have a new camera. I don't know if you can see that red on the back there. This is a camera that I bought, not that long ago, to learn about and to develop some what's called electronically assisted astronomy, EAA. So this is something between looking through a telescope with your eye and using a very sensitive CCD digital camera to take images of something. This camera rather, is a CMOS camera, and it can read out very quickly to act sort of like a video camera. Or you can take long exposures and treat it something like a deep sky or astronomy camera. So you can take images of nebulae and galaxies and things like that. So I have a view right now, if anyone recognizes this target that I'm looking at. Looks like the moon. Am I looking at the moon? No, I am definitely not looking at the moon. We have a post full moon. Now, last Thursday was full moon, so we're now getting close to last quarter moon. And the last quarter moon doesn't rise until midnight. And that's certainly not a last quarter moon right there. This is the planet Venus, which is getting low in the west at sunset. It's actually not quite sunset here. I can see now the sun is still shining on the I-95 bridge down there, but it's no longer shining on any of the land. It's just shining on a little bit of the bridge. I guess that's the other bridge that's next to it. So sun's going down, sun's setting soon, but Venus is bright enough that you can actually see it through a medium-sized telescope during the day if you know where to look. And since this is a computer-controlled go-to mount, as long as I have it roughly calibrated when I turn it on, I can say, okay, go to Venus even when it's still daylight, and I can actually potentially find it. So I'm tracking Venus there in the sky. If you don't believe me, I can move the telescope around a little bit so you can see Venus moving live there through the view. And I think it's really remarkable how thinly illuminated Venus is right there. It really does look like a crescent moon or a banana or something like that. And of course, this is because Venus is coming between the Earth and the Sun. So the part that's dark of this circle of Venus is the night side of Venus, and the part that's light is the day side of Venus. And we're just seeing a sliver of the illuminated globe of Venus. Now, if this were the moon, something else you would notice would be Earth shine. So when the moon is a young crescent like this, you may have never noticing this, although if you saw a photo of the crescent moon or if you saw the crescent moon in the sky, you would say, oh yeah, I've seen that before. The dark part of the moon is not completely dark. And that's because when the moon is new or crescent, when it's looking at the Earth is full. The Earth is fully illuminated, so the moon would be looking at the day side of the Earth. And the full Earth is quite bright. So if you were standing on the moon with the full Earth overhead, it would actually cast a lot of light. And so some of that light bounces off the dark side of the moon back to the Earth, and we see reflected Earth shine. So it's going from the sun to the Earth to the moon, and then back to the Earth again, so that you see it as reflected Earth shine. And Venus, of course, has none of that. Venus is much too far away to experience Earth shine. Earth looks just like a dot. In fact, Earth and Venus have almost the same physical size. They have about the same radius, diameter, whatever you prefer. And so if there were someone on Venus looking at us right now, Earth would be the same apparent size in the sky. And you could look at it with a telescope and it would have this apparent size. But the Earth would not be illuminated with this phase. It would be more fully illuminated, of course. Anyway, so Venus is basically the only thing I can really see right now, given that it's not quite dark yet. So let me switch over to my laptop camera, and let me switch over to my sky simulator. I'll keep an eye on Venus, though, and at some point it's going to go behind the dome of the 16-inch telescope, and I won't be able to see it anymore. So here I am in Stellarium again, and I'm going to talk about what's up in the sky tonight. Feel free to ask questions if anyone has any questions. There's the sun going down, not quite below the horizon yet, so we're not quite to sunset yet. And look over here to the east. One thing that you see when the sun goes down is you can see the shadow of the Earth coming up. And I think I see it coming up over there. So actually, let me try and show you what I'm talking about in the actual sky. So I'm going to try to switch back to my external camera and not lose my microphone. And I'm going to swing the camera around here so you can see the horizon off to the southeast. So do you see that pink light just above the horizon, and then it kind of fades to a dark blue light? I could try to put my finger in here and point at what I'm talking about, although it won't be in focus. You see the horizon and then some pink light and then some blue light. So something you can notice anywhere in the world, but this is especially noticeable at high altitude, is when the sun goes down, the Earth's shadow is passing through the Earth's atmosphere, and you can actually see the Earth's shadow rise opposite the sunset. I still see a little bit of sunlight down there on the bridge, so I don't think the sun has completely gone below the horizon, although it's definitely fading, so it's definitely coming up. I see a little bit of the shadow of the Earth kind of in the valley there between the power plant and the hill over there. So that's something that you can look for. I've seen it really dramatically on airplane flights. So if you happen to be on an airplane, if we ever fly on airplanes again, if you're ever on an airplane and you happen to be looking out the window when the sun goes down, you'll notice this kind of dark shaft, or this dark band coming up opposite the sun, which is the shadow of the Earth as seen in the Earth's atmosphere. I've heard it called the belt of Venus. I guess that's a poetic name for the phenomenon, but it's the shadow of the Earth coming up. All right, back to my simulator here. So let's see what's up in the sky. So things haven't changed dramatically since last week or the week before. Let's go a little bit later in the evening so that we can clearly see the stars. I brought in my 2x54 binoculars to enjoy the clear skies that we have here when it gets a little bit darker. All right, so looking to the east, I see those bright late spring constellations and stars coming up that I mentioned last time. Let's swing back over here to the west and label the constellations for us. Okay, so I talked a lot a couple of weeks ago about Gemini, Cancer, and Leo. So they're getting lower at sunset, so we're losing those. Those are kind of early to mid-spring constellations. Actually, one of the first targets I could potentially point at after Venus, when Venus goes behind the dome, is Iota Cancri, that star that I talked about last time, the northern claw or the right claw of Cancer. And then if we sort of look overhead, we've got the Big Dipper. Let me swing around to the north so we can look very clearly at it. One of the nice things about being here at the observatory to do public night or teaching or anything like that, whatever I'm doing remotely, is that I've got a much wider horizon than I do in my backyard. So we do have some trees over here to the northeast, and a tree over here almost due south, and the building is due north. But otherwise, we have a pretty clear view of the horizon. Oh, I really see that dark band coming up. I can't resist showing this again and again. Let me show this one more time. All right, so you can really see that purple-pink band that's darker at the bottom coming up. And it's going to rise at the same rate that the sun is setting, or it's rising at the same rate that the Earth is turning. So if we had a full moon, you would actually see the full moon kind of in that band, rising just as the sun is setting. So it's a beautiful phenomenon. Again, as I said, it's more obvious when you see it from higher altitudes. and I'm still pointed at Venus with the 8-inch telescope. Although I can't really see it with my naked eye up above the dome. I'm still getting it in the video camera. Let's see, I have a question here. Why doesn't Venus have a moon or moons? That's a good question. Probably, I mean, why does the Earth have a moon? Or why does Mars? Mars has 2 small moons that are probably captured asteroids. It's thought that big terrestrial moons of terrestrial planets are not that common, just because of the way they form. You know, Jupiter and Saturn have dozens of moons. Saturn's up to 80-something moons now. And they form around the planet as a consequence of how a gas giant planet forms. But when a terrestrial planet like the Earth or Venus, when they form, you don't get the same kind of disk of material forming around the planet. So it's a different mechanism. Probably the way the Earth's moon formed was through a collision of a large object with the Earth. So we have a show about that. That talks about how the Earth's moon probably formed as a consequence of a rare collision with a large object. You know what? Let's see what Venus is looking like. No real change. Yep, just getting lower and lower. Okay, back to the simulator here. So when it gets dark, if we look to the north, we have the Big Dipper almost overhead, a little bit north of overhead, and easy to find. It's a great time to find the Big Dipper, mid to late May, high in the northern sky at sunset. And if you're a little bit further north, it's actually almost directly overhead. And as I've said in many planetarium shows, the 2 stars at the end of the cup will point to Polaris, the North Star. And then if you use the handle of the Big Dipper, we say that you follow the curve, you arc to Arcturus, and continue, and you'll spy Spica, which is the brightest star in the constellation of Virgo. So again, I'll turn on the ecliptic. This is the plane of the solar system. So we always see the sun and the moon and the naked eye planets close to that orange line going across the sky of Stellarium. So we just have Venus kind of over here low in the west, and Venus is heading around between the Earth and the Sun to go to the other side of the Sun in our sky, when we'll see it as a morning star rather than as an evening star. So Venus is about to go retrograde, and I said I might talk about that. I'll give a demo of that in just a second. Something I want to talk about tonight are some of the interesting objects over here in the direction of Leo, Virgo, Coma Berenices, and Corvus and Crater. So over in this direction, there are a lot of galaxies. So if we zoom in a little bit, you can see these red ovals are all indications of galaxies. So what's a galaxy? A galaxy like the Milky Way is its own gravitationally bound group of stars, hundreds of billions of stars, and a similar amount of mass in hydrogen gas and other gases. Isolated from the other galaxies, but also usually orbiting around in galaxy clusters. Now let me zoom in just a little bit more, and there's an interesting area up here kind of between Virgo and Leo, and this is what we call the Virgo cluster. So there's a cluster of galaxies, thousands of galaxies, some of them as big as the Milky Way, but most of them much smaller than the Milky Way. And some of them, well, a couple of them bigger than the Milky Way, more massive than the Milky Way. And so it's very interesting that there's so many galaxies over in this part of the sky. You know, if I look over sort of more in the direction of Gemini, and I should actually point out the bright stars that are still out. I told you how to find Arcturus and Spica. And then if you look more to the west, so to the right from Spica, you see the bright star Regulus in Leo. And Leo is easy to recognize because of the backwards question mark here at the front. And if you keep going in that same direction, Cancer is a very dim constellation. It's hard to see any of the stars in Cancer unless you have really dark skies. But if you keep going, you'll see Pollux and Castor. And Pollux is the brighter of the 2 stars. Pollux and Castor are the 2 stars in Gemini. Pollux is the brighter of the 2 stars in Gemini. So Pollux is a little bit redder and a little bit brighter than Castor. Anyway, so those are the bright stars that you should be able to see. Gemini are almost, the two stars in Gemini are almost horizontal to the horizon at sunset right now. So they're among the first stars I'll expect to see pop out of the twilight sky when it gets dark enough. Anyway, back to the galaxies that I was talking about. Someone asked, is the space between galaxies empty space? No. I mean, there's really no place that's truly empty space, although the space between galaxies gets as close as you can in the universe. Really, it's the space between galaxy clusters and galaxy superclusters that's more empty, and I'll show you what I'm talking about here in a minute. Are there stars that are not part of galaxies? Not very many. Stars form in galaxies, and then the space between the galaxies is mostly empty, although depending on if a galaxy has interacted with another galaxy gravitationally recently, they'll pull stars and gas off of each other. There's still clouds of primordial hydrogen gas floating around out there in intergalactic space from the Big Bang. And occasionally stars will get kicked out of their galaxies through some random gravitational slingshot or something that happens sometimes when there's a supernova explosion. The neutron star or the black hole that's formed from the supernova will get a kick, and it can actually achieve escape velocity from the gravity, and it will be flung out into the halo and then out into intergalactic space. So there are definitely rogue stars out there between the galaxies. So back to the galaxies here in Leo. If you actually sort of, I was going to show you how there are no galaxies kind of over here. If I look over here in the direction of, say, Gemini and kind of zoom in, I just see a lot of stars. And these are stars that are in the Milky Way. Of course, all of the stars that you see as isolated stars with the naked eye or with binoculars or a telescope are in the Milky Way. But I'm not seeing, there's some star clusters and there's a beautiful nebula right there, but I don't really see those big clusters of ovals like I do with over here in the direction of Leo. So what's going on here? Well, just like stars will form in galaxies, galaxies tend to form in these big galaxy clusters. And if I actually just sort of scroll up and down, right here in the direction of the Virgo cluster with the M87 galaxy kind of in the middle of this big cluster, there's the Virgo galaxy. This is a galaxy that's about 10 times the mass of the Milky Way. So it's a beast of a galaxy. And it's probably gotten that way by eating other galaxies. But let me scroll back out, and I'm just going to sort of scroll down. More galaxies, more galaxies, more galaxies. There's just a whole line of galaxies that goes from the constellation of Virgo down through. There's the Sombrero galaxy. That would actually be an interesting target tonight. Maybe we'll try and look at that one. It's a little bit low here, but we could maybe get it. Down, down, down. A colleague of mine, Eric Briggs, he was saying last week for Cinco de Mayo, he really wanted to get a picture of the Sombrero galaxy to celebrate Cinco de Mayo. Good going, Eric. Anyway, scrolling down, more red ovals, more red ovals. Now there's a yellow cross. That is a star cluster that's in the Milky Way. That's a globular star cluster. So that's in the foreground in the halo of the Milky Way. Now I'm hitting the horizon, but if I could keep going down, there's Centaurus A. What I can do in my simulator is actually hide the ground. So if I click on Centaurus A, the Hamburger galaxy, no, there's another galaxy that's more commonly known as the Hamburger galaxy. But if I could zoom in on it here, you can see it is an unusual looking galaxy. It's like a big, enormous ball of stars with this weird lane of dust across the middle of it. Let's see, there's another question here. Where is TGE telescope black hole? Are you talking about the Event Horizon black hole, the one that was announced last year? The first image of the event horizon of a black hole. That was an image of the supermassive black hole that is in the M87 Virgo A galaxy. So when you look at this big galaxy right here, it's quite far away. I think it's about 55 million light years. I think that's right off the top of my head. Probably if I click on it, the simulator would tell me Somewhere in there is the distance. But this is the one that the Event Horizon telescope took a picture of. It actually took several years to get the data, and the image was released last year, the first image of the Event Horizon of a black hole. Even though it's so far away, the black hole is so big that it was the best one for them to try and take a picture of. Is that the ISS moving from right to left? I don't think the ISS is up tonight. I've been looking to see if the ISS would do a pass on a public night or one of the nights that I'm up here. It looks like most of the space station passes have been in the morning lately, but that would be an interesting thing to track with a telescope, and we could potentially track it. Actually, with the telescope that's back behind me with the tarp over it, we can use that to actually track satellites. If you were on a planet in the Virgo cluster, would the night sky be significantly brighter than our night sky? No. You know, there would be more bright galaxies. I'm trying to think, would any of them be naked eye galaxies? Yeah, actually some of them would definitely be naked eye galaxies. There are 4 galaxies you can see with the naked eye from the Earth if you're in a place where the sky is really dark. So that's, of course, the Milky Way is our galaxy, and you can see it with the naked eye if the sky is really dark. You can see it from the inside out. There is the Andromeda Galaxy, which is the closest big spiral galaxy to us. And it's actually pretty obvious when the sky is really dark. It's quite bright and big. And then there are the 2 satellite galaxies, the Magellanic Clouds, the large and small Magellanic Cloud, which you can only see in the southern hemisphere. But the sky wouldn't be that much brighter. I mean, the galaxies are far away, so they're not casting a lot of light. Now, if you were in one of these globular star clusters like M3, you know, the star cluster that I talked about last week, you know, if you were in one of these dense globular clusters near the center, there would be a lot more bright stars all over the sky, which would be really dramatic. Anyway, I'll go the other way as well. So if we go back to Virgo and zoom in, and if we kind of scroll our way up, we get out of the Virgo cluster and start to move into the Comet cluster, which is further away. I think the Comet cluster, again, off the top of my head, is maybe 100 million light years. Here's part of the Comet cluster right here. So the galaxies are smaller and dimmer. And then if we keep going, you know, same direction, more galaxies. All these little red and orange ovals are galaxies. Keep going up. We can go all the way up to, there I just went through the zenith, the point directly overhead. Keep going up. I can go all the way up to the Big Dipper. Here's the cup of the Big Dipper. And I'm still seeing all of these red ovals all over the place. There are some famous ones over here. So for example, here is the M101, the Pinwheel Galaxy, beautiful face-on spiral with these big open arms. Maybe we'll try to take a picture of it tonight if it gets dark enough. And also in the direction of the Big Dipper handle is M51, which is called the Whirlpool Galaxy. It's actually 2 galaxies close together. So there you can see what that one looks like in the simulator. So one of the things that I'm working on that's going to be part of our research project. Let me just zoom back out to the Virgo cluster here. There we go. One of the things that I'm going to be working on this summer with my students is monitoring supernova explosions in other galaxies. So when massive stars die, they go supernova. Their core collapses to form a black hole, perhaps, and the outer layers expand and become this hot, cooling, expanding shell. Eventually turning into a supernova remnant. The elements that were forged in that massive star get dispersed into the rest of the galaxy, perhaps to form new stars and new planets in the future. And so I'm looking for bright supernovae to get test data and to test the equipment and talk about with my students when we actually start our summer program at the end of June. So this is one of the things that I've been working on, hoping to come up to the observatory, and then once I finally got to come up to the observatory. And let me switch over and show you a couple of images. Let's see how Venus is doing. We'll switch back to Venus here for a second. Looks good. Getting darker, but we're still in twilight. Oh, you know what I'm going to do next. I'm going to switch to the shadow over there because it's looking really clear. All right, so now do you believe me? Yeah, so see this, there's this sort of pink in the transition right about here, and then this dark band rising up, and then sort of pale blue sky that's going to fade to gray as the sky gets darker over in that direction. And can we see Venus if I sort of look down the side of the telescope? Can we see it up in the sky yet? Anyone see it? Anyone see where the telescope's pointing? I can't see it with my naked eye yet. Maybe I could see it with the binoculars. I could try that. So, I did manage to take a couple of test images. Let me switch over to my laptop camera. So I did manage to take a couple of test images with this camera and with this telescope a couple of nights ago when it was clear. It's been chilly. It's been quite, even when it's clear, the air is pretty chilly, and it's been windy also. So that hasn't been that great for taking images with telescopes. But I thought I would show you a couple of these images, and then if it gets dark enough, we can actually look at some with this telescope in live, which will be a great test for this camera. It's one of the things that I've wanted to do with this camera. And a little bit about astronomy news before we go on to look at some galaxies. There is another comet coming along. So a month ago I talked about Comet Atlas, which was projected to become a naked eye comet by the end of May, but then it broke apart and faded. But there's another potentially naked eye comet, Comet SWAN, which has the designation 2020 F8. That's the technical provisional designation. And here's a picture from Botswana through, looks like a SLR camera with a zoom lens. And so I was curious to know, okay, well, is it going to be visible from New Haven with a small telescope? Could I look at it tonight at sunset? And it's going to be a little while, maybe towards the end of the month, right at sunset, looking to the northwest. You have the chance to see this comet with the naked eye. So we'll keep an eye on it. As I said with Comet Atlas, anytime I want to know the details of an asteroid or a comet or some new solar system object, I always go to the JPL Horizons website. And so I wanted to know, okay, will this comet be visible at sunset any night this week from the Leitner Observatory? And so I have here every night until May 31st, the position of the comet and the brightness of the comet and the distance of the comet. And it's looking good. It's going to get higher at sunsets sort of right towards the end of May. It's going to potentially be visible from here in New Haven. But it's not really naked eye based on this projection. Maybe it will get naked eye, but it could be an interesting comet to look at with binoculars. I was curious about what the orbit of this comet is, so I went and looked at the orbit diagram. And here you see the Earth over here, and there you see the sun right there, and there's Venus going between the Earth and the sun. And this sort of white line with all of the drop-down bars, that is the orbit of the comet. And you can see where the comet is right now. So it's that dot right there. So it was a little bit closer in the past. It's getting a little bit further away from us and closer to the sun. The path that it's taking is up through the plane of the solar system up to this place right here, which is the perihelion point. That's where it's going to be closest to the sun. And then it's going to come back down and go south through the plane of the solar system and then back out to the Oort cloud, wherever it came from. It's not an interstellar comet. It has a closed orbit, but it has a very long, elongated comet. So it's not going to come back in anyone's lifetime. We're not going to see this comet again. So maybe naked eye under really great circumstances, but probably not. Probably a binocular comet. So if that is visible from here on a public night, we'll definitely take a look at it. Well, let me show you one of the galaxies that I was looking at through this telescope with this camera the other night. So this is the galaxy called NGC 2903. So it's a barred spiral galaxy. It's in the direction of Leo, kind of between Leo and Cancer. And this was a very quick image that I took. I think I spent about 10 minutes on this image. Using the new camera to just test it out. So I didn't do a lot of calibration. I didn't do a lot of noise reduction. You know, there are astrophotographers who can do a much better job at this. I'll zoom in a little bit on it. But I was pretty happy with that image taken from the middle of a city at sea level with an 8-inch telescope. This is promising. Another nice thing about this camera is that it produces color images. So most astronomy cameras will take black and white images, which is better. It means you can see fainter things. But since this camera is intended for live viewing or for amateur astronomy, it actually takes color images. This is what the galaxy looks like with a better amateur telescope. This isn't a professional observatory telescope, a professional astronomer's image of the galaxy, but you can really clearly see these spiral arms that open up. You can see the star formation regions in the galaxy, very beautiful. You can see the bar in the galaxy down here. So this is a really beautiful galaxy. Last week, someone asked if we could look at the M51 galaxy from my backyard, and the problem was that the trees just to the north of where I had the telescope set up blocked the whole northern sky. So I don't have that problem here at the Leitner Observatory. So the other night I got a quick, again about a 10 minutes worth of work with this same telescope and this same mount and the same camera to take this picture of M51, the Whirlpool galaxy. So I can zoom in on it a little bit, and you can see, yeah, it's kind of noisy. It's not a perfect image, but it really does show you kind of what the galaxy looks like. It looks just like a perfect spiral, just this beautiful, almost logarithmic spiral type of shape. And then this other galaxy right here, which is actually a little bit behind the main spiral galaxy. And it's almost certainly the case that there's been some interaction between these two galaxies that's led to the shape of this galaxy and the shape of this galaxy. They interact gravitationally. So I was interested in finding a galaxy that had a supernova. And it turns out that there is a bright galaxy in the Virgo-Leo area cluster that does have a supernova. By the way, I was talking about galaxy clusters before, and I pulled up this image just in case someone asked about it. This is a map of galaxies out to 4 billion light years, taken with a big telescope in New Mexico over many years. It took many years to actually produce this map of the nearby universe. The Milky Way is right here at the center, and every blue dot is the position of a galaxy. And so you can see that the galaxies, yes, they really do stay mostly in clusters. Now there are some big open areas, these voids between the galaxy clusters, like right here and right here and right here. And so it's interesting to ask, why are there these big open voids where there's not very much, there are very few galaxies, there's probably not very much gas, certainly not stars. And it has to do with the way that the galaxies form after the Big Bang, and the way that dark matter clumps up after the Big Bang. Getting a little technical here. And galaxies actually form in those clumps, and that leads to galaxy clusters and then superclusters, and you kind of have this hierarchy of galaxies in the universe. And of course, that's the real reason why there's this big line of galaxies across the sky from Centaurus A all the way up to the Big Dipper across the May sky, May at sunset sky. Anyway, as I said a minute ago, I was looking for galaxies with bright supernovae. So what happens in a spiral galaxy like this is that it's making stars. Stars are forming from the gas and dust in the galaxy. You can see that really clearly here with this image of M61. I should give credit to the actual astronomer who took this picture. But you can see really clearly those kind of pink patches in there. Those are nebulae where stars are forming, basically the equivalent of Orion Nebula for us, or the Lagoon Nebula for us. Um, let's see, what would we, I think probably this time of year we might look at the Orion Nebula, and then in the summer we might look at the Eagle Nebula during public night to show an example of a star-forming region. They glow with this pink color because that's the color of ionized hydrogen. The stars form and they put out this ultraviolet radiation, and it ionizes the gas nearby, and the gas fluoresces like a fluorescent light bulb to glow with this very distinctive pink glow. Anyway, new stars form in those star-forming regions, and they make clusters. And the massive stars, they run out of fuel very quickly. Their core becomes pure iron, collapses under its own weight. Is an amazing story. The core collapses under its own weight, the star explodes and becomes a supernova. And a supernova can be as bright as a galaxy for a few weeks or a month or so. And so my summer students are going to be doing research on supernovae that are going off in other galaxies. So I was looking at the list of recent supernovae that have happened, and it looks like there's a supernova in the M61 galaxy. So if I show you where that is in the simulator, let me just try to bring that up here. So M61 is sort of over in this direction, and rather than hunt for it, I should just do a search. There it is, okay. So swelling spiral galaxy, that's, some people call it that. So, you know, if I zoom in on it, you can see there's a professional image of it. We're seeing it more or less face on, kind of perpendicular to the disk of stars and gas and dust. And there was an announcement that a supernova had gone off in M61. So I was pretty excited about that because it's quite close. It's less than 60 million light years away. So the supernova could get quite bright. So the other day I took a picture of M61, and I don't know, is there a supernova there? Let's look at the galaxy. So I'm going to zoom in on it a little bit. Now this is an image that I took with a filter using the 16-inch telescope behind me. And it's not completely properly calibrated, so there's some weirdness in the background, some dust specks and things like that. But I was interested in seeing the star points to try and find the potential supernova. So there's the center of the galaxy. It's got this kind of boxy shape, which is interesting. There's some knots of star formation in the spiral arms. And if there were a supernova, it would look like just a star. Now, all of these stars that you see in the picture are stars that are in the Milky Way, in the foreground. They just happen to lie in the direction of the M61 galaxy. What I need to do is compare this image that I took 2 nights ago, I think it was, with an archived image from a professional telescope that's done a survey of the whole sky, or an image that I might have taken of this galaxy in the past when there was no supernova. So let me go get an image from a survey. All right, we'll see if this works. Okay, so on the left side, we'll see if this works. Okay, so on the left side of the screen is an archived image taken from the Palomar Observatory in California. And on the right side of the screen is the image that I took with the 16-inch telescope at the Leitner Observatory recently. So I'm looking for a new star in this image. This is like what's different between these two pictures. Now, obviously the contrast and the brightness are different, and the scale is a little different, right? This image is a little bit smaller in scale than this image over here. But you can definitely see the orientation is correct, right? If you look at this kind of knot of stars right here, and this knot of probably not stars, but actually star formation. I don't think my cursor's lining up correctly, but anyway, this knot of stars at the top of the spiral galaxy lines up with a knot of stars at the top of my image. Okay, let's see, this star at the top, let's see if I can get my cursor to line up properly. This star lines up, I think, with that star, okay. And this star, this star here lines up, I think, with that star there. And this star here, can I get it? This star here, I think, lines up with this star here. Anyone see the supernova? There is, in fact, a bright supernova in this galaxy, and it's right there. And it's what we call a type 2 supernova, which is when a massive star has collapsed and the outer layers have exploded. And this was actually recently discovered. The first week of May, this supernova was discovered. These ones that are in galaxies that are quite close are discovered very quickly. There are telescopes looking at hundreds of galaxies every night, looking for new stars in the galaxy that would be evidence of a supernova, so that astronomers can study them. Many of them are only looked at by robotic telescopes, so it's unusual for actual astronomers to go study, unless it's a very unusual supernova. But I'm excited to have heard about this supernova. Now, it's going to have faded by the time my students start working on their projects, so it won't be a candidate for research for a project. But I'm going to monitor it when I can, and I'm going to take some spectra of it with our spectrograph using the 0.4 meter telescope, the 60-inch telescope behind me. And so excited to get some results on this nearby supernova. All right, I think Venus is going behind the dome. Let me see if there's anything else I wanted to say about galaxies before I go on. I'll switch back to my archived image here. And anyone have any questions about galaxies before I go on? I don't think I have anything else to say. I did go and find an archived image in color of M61, so you can really see the bluish stars in the spiral arms here. Now remember that these points of light are stars in the Milky Way in the foreground. They just happen to lie in the direction of the M61 galaxy. But you can actually see in my image that the supernova is actually that one right there. The supernova appears as bright as a star in the Milky Way, even though it's more than 50 million, about 50 million light years away. So these stars are a few thousand light years away. That supernova is more than 50 million light years away, and it appears about the same brightness. So it's a very, very luminous object. Okay, I'm going to switch over to the telescope and see if there are any other interesting objects that we can look at. And when I switch over, I'll go back to the external cam here. Okay, there we go. Yeah, there's Venus, still looking good. Not quite below the dome. It's looking a little bit blurrier and more shimmery, and that's because of the atmosphere, although I can perhaps change the exposure a little bit to try and improve that, make it a little bit easier to see the shape of Venus. Yeah, it still looks like a crescent. Well, I'm going to try to move to a bright star just to do a little bit of pointing calibration, and then I will try to find an interesting object, maybe starting with a bright star cluster before going to the double star Iota Cancri. And then by 8:30 or 8:45 or so, it should be dark enough to try and see a galaxy through this telescope. So I'd love to do that. My 6-year-old is asking, what's causing the bright light at the center of galaxies? That's a great question. What's going on at the center of the galaxies is there are a lot of stars there in the center. So actually, if I show this image again, if you look there in the middle, it looks like there's a star. There's just one star right in the middle of the galaxy. No, there are billions of stars, billions of old stars in what we call the bulge of a typical spiral galaxy. Old stars orbiting around each other that have been there since the formation of the galaxy, and those galactic bulges can be quite bright. In fact, the bulge of the Milky Way is very bright, and you can see it from the Earth in our summer. in the months of sort of June, July, August, depending on the time of night. So winter, southern hemisphere, our summer. It's unfortunately quite low in the sky from New Haven and from the northern hemisphere, but the bulge of the Milky Way is very bright. And so if you have the chance to go to the southern hemisphere when it's winter there, so again, June, July, August, and go someplace where the sky is really dark and look for the Milky Way bulge high overhead, it's really spectacular. So I had the chance to see that in Africa some years ago, many years ago. I had the chance to see that. So it was amazing, something I'll never forget. Okay, let's move the telescope. So I'm going to switch back to this view. And I'm going to, I have kind of a house of cards set up on this little laptop here, trying to do many things at once. But I'm going to try to move to the star Pollux. So let's see if it works. All right, so you can see and maybe hear the telescope moving over in that direction. And if we're lucky, it'll show right up in the camera, but that's unlikely. I'll probably have to nudge the telescope over a little bit. Oh wait, I think I do see it actually there. I'm just going to confirm. I think that's the star right there. Can everyone see that bright point right there? Lower the contrast a little bit here. Make it a little bit brighter. So I'm just going to confirm by checking the finder scope on the telescope, but I think that's it. So telescope mount is surprisingly well calibrated. Yep, that's it. It's right there. So that little dot there is the brighter star of the two bright stars in Gemini. So even though it's not completely dark, we're still in twilight. It's coming through the Agnes telescope and also through the finder scope. It's not showing up in color here. I think I probably have to do something to turn on color, although the color of the star is not that obvious. Let's see saturation if I pump that up. Let's move over to Iota Cancri and see if we see two stars, because Iota Cancri is a double star. So I will show you what I'm looking at in Stellarium so you can follow along with me. You know, if you're in a place where you can go out, you know, in your backyard to your deck or someplace where you can actually see the star, we can talk together about the stars that are coming out as the sky gets dark. And I've got my binoculars here so I can try and find some of them as it gets dark. But let me show you what we're going to be looking at. All right, I'm still zoomed in there on that galaxy. So I'll zoom back out. So I just did a quick calibration pointing on the star Pollux right here. Let me clean this up a little bit. I haven't talked that much in these live streams about star lore, you know, the stories about the constellations and things like that. But if that's something people are interested in, I'd be happy to talk more about the star lore and the stories of the constellations. I think most people know the story of the twins, right? The Greek myth of Gemini. So the telescope's pointed right now at Pollux, and I'm going to move it to this star right here, Iota Cancri. So let's see again if this works, or if the telescope or the software crashes. All right. All right, there it is. And yeah, I can definitely see two stars. It's not perfectly centered, so let's move the telescope down. Oh, and I can see the color. All right, we're going to zoom in on these a little bit. And I'm still learning this software, so you're going to have to bear with me as I try to zoom in. Let's try the plus sign and see if that lets us zoom in. It does. I'm zoomed in so much now I can see the stars twinkling. All right, I'm going to try to raise the exposure time. So we see those stars a little more clearly. The focus is good. I'm astonished that the focus is so good. And I'm going to try to increase the saturation so the color is a little bit more obvious. And make the sky a little bit blacker. All right, there we go. Live view of the star Iota Cancri from the 8-inch telescope on the observing deck of the Leitner Observatory. What do you think? So this is one of my favorite objects to look at public night or in student labs in the early spring to late to mid-spring. Of course, classes would be out by now, and the star is getting kind of low at sunset. But I like to ask my students, are the stars the same brightness? I should say, these two stars are orbiting around their common center of mass. This is a true binary star system. So we got two stars at about the same distance from the Earth. I forget the exact distance, a few hundred light years. So are they the same brightness? Well, I think it's pretty obvious in the image. It's much clearer when you look with your eye at the eyepiece. And even though I'm doing electronic assisted astronomy here because I have to for a live stream, it's better to look with your eye. And it's really dramatic when you see the color difference and the brightness difference with your eye. I think most people would say that this star to the right and up is brighter. Okay, are they the same color? Okay, well, this is a digital camera, and I haven't really done careful color calibration and white balance correction and so forth. But no, I think most people would say there's a color cast, that the one in the upper right is kind of a yellowish, orangish white, and the one in the lower left is kind of a greenish, cyan, bluish white. You know, star colors are not dramatically primary colors like cobalt blue and fire engine red, but you do definitely see hues, and that's associated with the temperature of the star. So the star in the upper right is kind of a, let me actually see if I can get my cursor going here again. Okay, so the star in the upper right is cooler. It has a lower surface temperature than the star on the lower left. The star in the lower left is hotter. It's a bluish star, and the star in the upper right is a reddish star. So that's interesting. So they have different surface temperatures. Why would the stars have different temperatures? Why does any star have, why don't they all have the same temperature? Aren't they all burning hydrogen? Doesn't that happen at a certain temperature? Well, it has to do with the mass of the star and the size of the star. So the bluer star is hotter because it's more massive. The redder star is cooler because it's much, much bigger, physically bigger. It actually has a bigger size. So that makes it brighter and cooler. And it's probably a red giant star, whereas the blue star is still what we call a main sequence star. Like the sun, it's still burning hydrogen in its core, normal star, just like most of the stars you see in the sky. Someone's asking, do you recall their angular separation? I don't off the top of my head. I mean, the whole camera field of view is, I think, about 3/4 of a degree. So the angular separation is a few arc minutes, but I don't remember exactly. Maybe I would guess about 10 arc minutes, but I don't know that off the top of my head. I have to look it up or measure it. Okay, so that worked well. Let's move to another object, and I think I'm going to try to move to the Beehive cluster, which I know I've shown pictures of several times on these live streams, but let's see what it looks like given the twilight sky. Okay. I'm not using Stellarium to point the telescope. I'm using some different software. All right, so you may see the telescope move. And let's switch over. Let's take a look at the camera here. So I'm not really seeing, I see one bright star in there. I'm going to check the finder scope and make sure I'm pointed at the right place, but I suspect this object is too faint to see in video mode. Let me try. Increase the exposure, see if that helps. Yep, I see a few more stars appearing. So the star cluster is definitely there. Yeah, I do see it there, but the sky is still kind of bright, so not quite bright enough to see. The sky isn't dark enough really to see many stars in that star cluster popping off. Just a little bit too early to really see it. I'm going to take a look at the sky with my binoculars here. See how dark it's getting. Yeah, I see a few stars, but it's not very dark yet. That's probably Regulus there. Let's see if I can see the Big Dipper. Can't really see the Big Dipper. I'm going to try one more telescope pointing, and then what I may actually do is show a planetarium show, and then come back to some deep sky or some darker object imaging. People are interested in that. I'm going to try one more move. And move over to Regulus. Okay, so there it is. Now it's a little bit off center. You can see, get it centered here. But the color is clear there. Notice the color on Regulus. So this is the brightest star in the constellation of Leo. And you can actually find Regulus, if the sky is dark enough, you can see the Big Dipper. You can actually find Regulus if you take the two stars that are opposite the pointer stars in the cup. So the two stars at the end of the cup point to Polaris, the North Star, and then the other two stars in the cup, if you go the other way, they point to Regulus, right up there in that direction. And so the video camera is giving us that live image. And if I zoom in on that, you can see there's a companion for Regulus. You can actually see it when I zoom in enough. So Regulus has a companion that's kind of a faint, not really reddish, but whitish star. And Regulus is a bright blue star. So Regulus is one of these hot blue main sequence stars, probably an A-type star. So, actually what I'm going to do is try to take a longer exposure on maybe a bright galaxy. And it's not quite dark enough to see any, or maybe a bright star cluster. If anyone has any requests, I have a better chance of actually getting your getting your request in the telescope tonight than I did from my backyard. probably going to be easier to find things over in the eastern sky. So actually what I may try to do is point at the M3 star cluster over in the eastern sky, which is over in that direction. And I do see Arcturus up there in the sky. So that's where the star cluster is going to be. So give me a second. I'll point at Arcturus, and I've got to flip the telescope over to the other side so I can get over in that direction. And we'll see if we can find Arcturus and then the star cluster, and then a bright galaxy, and then I'll probably sign off for tonight. So let's go to Arcturus. All right, there it is in the camera. When I move all the way across the sky, of course, I have to do a little bit of alignment checking. So let's just get that centered. Oh, I'm still zoomed in, but you can now really see that. You can really see that star. Now, Arcturus is also a red giant, but it's quite close to us. It's only about 30 light years away. So I can very clearly see it in, I think we must be getting into astronomical twilight by now. I can clearly see it over in the east. It's going to be the brightest star over in that part of the sky, and I've got it centered here in my radical. Let me get it just centered a little bit better. So beautiful red-white star. All right, let's move over to the star cluster, and I may switch over to the longer exposure mode of this camera rather than the video mode. It's getting dark enough. I think I can probably see some star clusters and some fainter objects. Okay. So we might be pointing at the M3 star cluster now. So we'll take a longer exposure. So you notice the red lights are now sort of dominating the light. So we have these red lights for doing visual observations out here on the observing deck. And it helps you still see what you're doing when you're walking around, but it doesn't cause your pupil to constrict as much, so that when you look through the telescope, it's a little bit easier to see things. All right, we're getting some images. I see the star cluster. It's down here in the lower left. So to figure out, can I move the telescope while I'm still imaging? I think I have to start over. Let's see. Okay. Well, this is the thing, I'm taking 5-second exposures with the camera. This camera has a cooler built in, which is nice compared to my SLR camera, my Canon camera, which is just whatever the temperature of the air is. This camera will actually cool itself to lower temperatures. So let's try moving the telescope a little bit and see what that looks like. I think also I can scale it down a little bit. Okay. What we probably need to do is not, let's see. So this is the individual images. Let me try, because I think I know where it is. There it is, the M3 star cluster. Okay, so we're going to try to take some longer exposures. And the way this works is the software, every time it takes an image with the camera, it combines it with the other images, and you get a better image, better image, better image, and then eventually get an image that you can save. So it's kind of accumulating the light in the camera, which is a really nice feature. So let me make the sky a little bit darker. I don't know how I feel about this electronically assisted astronomy. I mean, I guess if you're doing a live stream or remote teaching, This is the only way to do astronomy, short of me mailing all my students a telescope like this and a mount and teaching them how to use it. It's pretty cool. You can do some interesting stuff with it, but it's not going to completely replace putting your eyeball up to the eyepiece of a telescope and seeing Saturn or a beautiful star cluster and going, wow, that's amazing. I can't believe I'm seeing that with my own eyes. Okay, so I'm seeing a pretty good image of this star cluster, the globular star cluster M3. So it's a cluster of a few 100,000 stars located out in the halo of the Milky Way, orbiting around with the other stars in the halo and in the disk. And that's actually looking pretty good. You can see down here, I hope everyone can see my images coming down. And I think what I'm going to do is move to a galaxy and take a few images. And unfortunately, there's some clouds coming in. I don't know if you can see that on the camera. But I will stop this readout and I'll save the image. That's the individual image, and then there's the combined image. The other thing that it does that's nice is that if the telescope is drifting at all because it's trying to track the star cluster across the sky, is it shifts the stars around so that they line up with each other. Anyone have a request for a galaxy? I kind of want to go to a Virgo cluster galaxy, but the clouds are rolling in that direction. All right, I just saved that image, so I'm going to go back to, so stopping the stack and go back to a 2-second exposure and about what galaxy I might want to go to. I mean, actually M51 is not a bad choice. Let's go to M51. It's kind of close to where I'm pointing in the sky right now. So if you're looking at the sky, if you look to the east, you see the bright star Arcturus, which is where the telescope is pointed basically right now, near that star cluster. And I'm going to swing kind of to the north. Oh, I see the Big Dipper now really clearly. So actually I'm going to look and see where that galaxy is. You can see the stars in the Big Dipper really clear. And there are no clouds where M51 is right now. So actually, let me show you where I'm going to point the telescope. Okay. So I'll show you in the simulator again. Okay, so back to the simulator here. And I'm pointed over here in the direction of Arcturus. So Arcturus was that bright reddish white star that we were looking at earlier to align when the telescope moved over. And then M3 is the star cluster that I'm pointing at right now that we just saw those images of. And we're going to go to, let's see, that's M101. We could do either M101 or M51. So there's the Big Dipper, and M101 is here, and M51 is here. And they're both really pretty galaxies, although M51 is a little bit brighter. Let's try M101. I don't know if it'll work or not. So I'm going to move the telescope to M101. Now, you know, the way that I'm taking these images is very slapdash. Let's just get a picture and see what's there, kind of fun, exciting thing to do. If I were doing science, where I wanted to really measure the color and the brightness of the stars, and so I would do some very careful calibrations, and I'd have my camera cooled down with liquid nitrogen, and it would take me all night to get the data. Let me move the telescope before I talk about this story. So move to M101. Okay, there goes the telescope. And if I were another thing, another way that people will often end up using a telescope and a camera like this are people who are really interested in astrophotography. So people who, amateur photographers or amateur astronomers who want to make really beautiful, aesthetically pleasing images of galaxies or nebulae or things, celestial objects, to publish in magazines or to sell photos of, or just as the just part of the challenge. So, you know, if I were taking a picture of this galaxy for purposes of either one of those purposes, I would be spending a lot of time working on calibration and staying up late, getting the best images and so forth. All right, let's switch back to the camera and we'll see if we can find this thing. Oh, we're getting some clouds. All right, we'll try a longer exposure. Turn the cooler on. All right, that is the cluster, so let's clear that. Ah, I think I see it. I think I see the core of that, of the galaxy. So let's see if I can center it without losing it. So there's that little, there it is right there. It's very faint, so it's hard to see. It's right there. I don't necessarily have to have it centered to take an exposure here, but just be able to see more of the galaxy if it's more in the center of the camera. Oh, I moved too far. It's way down at the bottom now. We'll see if we can get an acceptable public night live view of M101 using an 8-inch telescope from the middle of a city over a YouTube live stream. Okay, I think that's centered, so let's start saving images. So clear that. Okay, so I'm just going to sit here and watch the photons accumulate. So, and hope the clouds don't get in the way of my target, which they're not. Clouds aren't in the way right now. You can see down in the lower right of my window the exposure time, and every time this bar goes all the way to the right, it's going to load a new image. So you can see the bulge of the galaxy right there. The bulge is, you know, the brightest part, the part of the galaxy that's going to be easiest to see. Let me adjust the brightness and contrast a little bit. M51 is a little bit brighter, so maybe I should have chosen M51, but I think we'll probably see some spiral arms popping out here. All right, so Brett, thank you for this. What's your name? I'm Michael Faison. I think I forgot to say that at the beginning. I'm a faculty here in the astronomy department at Yale University, and I teach a lot of astronomy labs, and I'm the director of this facility, the Leitner Observatory and Planetarium, which I will remind you here at the end is not open to the public, sadly, for almost 10 years. Actually, more than 10 years we've been open to the public every Tuesday night, except for brief vacations. So trying to do some kind of live stream on clear nights at least, and planetarium shows on cloudy nights, so that our fans, Leitner Observatory fans, can still stay connected with us. Another question, how far away is M101? Off the top of my head, I don't know. I think it's sort of in that group associated with M51, so I'm thinking 20-something million light years, but I don't know off the top of my head. I would have to go look it up. Okay, let's see how we're doing here. Oh, clouds. All right, there's my single frame, which is a cloud. And there's my combined image. And I noticed a second ago it said the number of stars is not enough. So not getting enough images, enough stars in the image to add the image into the combined image. So this might be the best I get until it clears up, although it's getting more cloudy. I think I can see a little bit of a spiral arm here and a little bit of a spiral arm here, and I can definitely see the bulge, the central bulge, the stars in the center of the galaxy. But looks like I'm getting clouded out. I don't know if you can see in the background. I'll show you what the sky's looking like right now. So getting some clouds, and those clouds I saw in the west have swept over across the Big Dipper as well. Well, that's too bad. I was hoping to take another picture of M61 tonight before I go home, but definitely getting worse, and getting about time for me to pack up and head home. All right, well, I will put the camera on me for a second and see if there are any other questions before we call it a night. It is nice to be at the observatory tonight. Thank you for your patience. All right. What is a good starter telescope that I could see the planets with that's not too expensive? Yeah, well, so like I talked about in my not the very first live stream because that was inside, but the second live stream that I did that you can still see on the Leitner Observatory YouTube channel. You don't need to spend a lot of money to get into astronomy, even get into observing with telescopes. So in the second live stream that I did, April 28th, I think it was, I did a live view of the moon and Venus using a $150 4-inch refractor telescope that I got on Amazon for teaching purposes and just fun travel observing and things like that. So I would like to do a pre-recorded video at some point for the Leitner channel about how to pick a telescope. Of course, there are a lot of tutorials on YouTube and other places, Sky and Telescope, on what's the best telescope to get. you don't have to spend a lot of money. That telescope is about $150, and it comes with a really good tripod. There are some less expensive telescopes that you can buy, but you have to be careful that you're not getting a telescope that's so inexpensive that it has real flaws that are going to cause you to not want to use it and to push you away from getting into astronomy. So I actually, for people who are just getting into astronomy, a good option is a good pair of binoculars. You know, good 10 by 50 or even 8 by 42 binoculars like you'd use for bird watching or something like that. And there's so many things that you can see with that. Now, Richard asked about especially looking at planets. So a good option for looking at planets is a refractor. An inexpensive refractor with an aperture of at least 80 millimeters. You can get some that they start around 50 millimeters. That's the size of the lens. But I really don't think it's worth buying a telescope with a lens that's smaller than 80 millimeters in aperture. You're going to get sharper views and brighter views with a bigger lens. And so I'd say not smaller than 80. And 90 is a good compromise for a refractor. And it will come with eyepieces that will give you up to 150, 200x magnification, which is certainly adequate for looking at planets. And it will come with a tripod that will be sturdy enough so you can point at the planet and look through it and get a good view. And Jupiter and Saturn are going to be beautiful this summer. So two objects that are really nice to look at through the telescope. And an inexpensive refractor can do that for you. If you want a slightly more fancy telescope for about the same price, you can get a 5 or 6 inch reflecting telescope. So I'll try to make a video about what I think are good options for beginner telescopes and find some other recommended articles about that. At times we've had a how to use a telescope class here at Leitner for people, so maybe I'll do a video version of that, or someday we'll do that again here at the observatory. Okay, well, thanks for the appreciation, and if anyone has any questions for me, you can send me an email. The email for the observatory is info@leitnerobservatory.org. My email is michael.faison, Faison, @yale.edu. And you can look at our website to see what events are coming up, online events for now. So that's Leitner Observatory, Leitner observatory.yale.edu. And the link to the live stream is always posted there. And I try to remember to post a link for the live stream on Facebook and Twitter. So on Twitter, we're at LFOP. So you can also tweet at us if you like. So twitter.com/LFOP. So again, thanks for joining me tonight on what was a nice clear night for a while, and beautiful views of Jupiter and some stars and the star cluster. And I'll sign off for now and see you next time.